for me and for my company during these years. So I'm happy to share my experience, and thank you, Sergio, for this invite.
That is fantastic. So just a little bit of housekeeping. We have people on Zoom, we have people on YouTube. Feel free to use the Q&A section for asking questions, either during the session or afterwards, and I will be moderating those questions. What we're going to have today is more of a fireside chat, where Angel and I will be talking in the same way that what we do several times, just with a beer, but it's a bit early for that today. But we're going to try to touch on some of the points on how it is really to start a company in AI, and the journey on that, and the goods and the bads, and the roller coaster, emotional roller coaster of a startup. And we will also tackle the profiles and how it's hiding nowadays, and what type of profiles you look for, and how do you vet or interview these profiles. But before we go deep into this, it would be fantastic if you could give us, Angela, a bit of an introduction of what is Restb.ai, what you guys do, what's your segment.
Okay, basically, as you said, I'm Angel. I am the founder, and in the first years of the company, also the CEO. And then I focused on the AI part, which is basically my part. Basically, we started this business late 2015. We started doing basically computer vision as a service via API, and providing computer vision services even before, I think, more or less at the same time, or even before that, the Google Vision started, and even before TensorFlow. So basically, we started late 2015, and then during 2016, we started providing these computer vision services and starting to find what business cases to solve. No, okay, now we have a computer vision technology. We built a kind of MVP of the platform at that time, and then said, okay, let's try to focus and find and talk with businesses, talk with companies to see what are the problems, if we can solve that problem with computer vision. At that point was like kind of magic. So basically it was then we can talk more deeply about that. And then basically over the years, we started focusing more on different markets. Then we narrow in basically one market, which is the real estate, which is where we are working right now. And yeah, right now we are offering computer vision services and image recognition services to companies more or less around the world, but focusing especially in the US and in Europe. Now we are processing around 4 billion images per year in our platform, more or less, for everybody to have an idea of the kind of scalability that you need when you provide this kind of services at the scale. And yeah, we are working on that. We're in the stage of we are growing, but now we are looking how to really scale the company. Now we are a 20 plus people company, more or less, with some offices in external offices also, with more people, 10 people. So more or less in total 33 people. And yeah, we started with 3, and now we are 33. It's
how many of those are engineers or data scientists or data engineers or AI?
More or less half of the team is technical team, and inside the technical team we have units of backend and frontend development, and AI and data oriented engineers also. It's nice. More or less half of the team is backend and frontend, and half of the team is AI and data. So it's more or less the system.
And I'll ask you more specific questions about this later, but since we're touching on this, how many of those are PhDs?
For now, no one.
Wow, well, that's really amazing. And again, we'll talk later. Put a pin on that because we'll talk about the profiles. But The reason I ask this is because there is also the idea that in order to be an AI or in these deep tech worlds, you need a PhD and way too much background in the algebra of what's going on. And but maybe you're implying that perhaps that's not the case or not the only way.
Exactly, it's not for me. It's not the only way. It's a current discussion in the field. I think for me, it's never mandatory to have a PhD because someone can have a lot of knowledge and a lot of experience on some field and then perform even better. Or, I mean, having a PhD is okay, it's nice and it's something that validates that you have some of the skills that are needed for research, but it's not like a 1 or 0, you know, it's not like a hard if. It's, for me, it's something additional that is so nice for some of the positions. Mainly for me, it makes more sense for fundamental research on AI probably, but for applied research and for industry applications, in my experience, and I had also some interviews with PhDs and not PhDs, I have not seen a big difference in some of the skills. It's just an opinion. I mean, here there are a lot of opinions. Like, this is just my experience and what I have seen so far. So
that's the beauty of science, right? We have the data, but then we can make anything we want
exactly,
about it, right? But let's put a pin on that, because on the second part of the session, I would like to dig deeper in hiring profiles and what type of data scientist or which vertical of data scientist or data engineer or data analyst can be good for which session. You mentioned before one really interesting point, that you build a platform, you build a technology, and then you started looking for segments.
Yeah.
Right. And this is something in the data science and big data masters we touch a lot on, because we not only want to build the hard skills on how to create models, classify, supervise and supervise, but also how to think about whether a business idea makes sense or not. So you don't put hundreds, thousands of development hours into something that then no one buys. Well, how was your trip in that?
Well, that's a very nice question. I mean, that was a lot of discussions that we had in the past in the company were around that. I mean, I think we started, and probably that was a mistake at the beginning. We started being pure technical people. I mean, we were like, okay, engineers passionate about AI. I had been working with algorithms in computer vision even before the deep learning explosion with the traditional computer vision algorithms. So we were so technical, our fundamentals were technical. And at the beginning, we built first the technology, and then we were trying to find a problem to solve. For us, that was at the beginning was a bit hard, was difficult. I mean, when you build first the technology and then you try to solve something, is what you said. You can be in something that, okay, you are investing a lot of hours, you are investing a lot of development, and then no one is going to buy your solution because you are not solving a real problem. And this is something that if I had to start the business again, probably I would like to do first market analysis, probably talk first with the companies even before coding and line of code, talking with companies, trying to validate first the idea and then apply the technology. But it's true that in a conversation, even also with you, Sergio, in our lunch, you said, but it's true that the technology first companies then have the ability to pivot, to change what they are doing in an easy way, no? And it's true. We were able to pivot. We were able then to find the problem, and then we started growing. So there is no an easy answer here. There is no an easy answer. But for example, I don't know, technologies or platforms like IBM Watson at the beginning, or companies like Clarify that were another reference in computer vision in the US, or also Google Vision. No, they build the technology and then they allow companies to solve problems. So there is not an easy answer. Probably for me, being a small company at the beginning, I probably now, if I have to start another business, I prefer to validate first, at least one first problem or two first problems, to focus on that instead of trying to do everything, because it's hard. The beginning was difficult, and we burn a lot of money. So that probably that questions are coming later.
So,
But
so maybe it's a little bit of on survival bias, right? Maybe you chose after this general approach, and you chose image recognition for real estate.
yeah.
Then you sort of hit the jackpot, or you groomed that jackpot, the combination of working very hard.
Yeah.
Well, what would it take? Imagine that you had to. Do you want to expand the business, or you have to pivot the business to a different vertical? I don't know, medical image recognition, just to name an example. Would it be easier for you to pivot all the structure that you have, the team and everything, or you would have to start from scratch?
In terms of technology, would be possible, because at the end of the day, this AI technology, I mean, these computer vision algorithms, they are, I mean, they can scale to another kind of problems, that can move to another kind of problems. It's true that then you have to experiment, to do experiments. You need to validate your algorithms on the data, because depending on the data, the performance is different. But obviously, it's not like from scratch. You can use a lot of what you have done to move to another vertical. For me, it's more a business tricky thing. It's a kind of, okay, knowing the market, knowing the players, knowing what's the problem, falling in love with the problem first, and then solving it with the technology, than in the other way. No, it's true that depending of the vertical. No, if you want to move to a image recognition for retail, probably is more or less the technology can be applied in the same way. If you move to medical, for example, there are a lot of challenges in AI to work with medical images because of the nature of the image of the data. But yeah, it's more like you can take advantage and use a lot of what you have done in terms of technology in this AI world, to move to another and to solve other problems. It's true that for me, it's more like a business challenge. It's trying to stay in focus and knowing the market. It's extremely important to know, because in AI, at the end of the day, you can do this. With AI, you can solve a lot of different problems, but each one of these models require extremely detailed requirements to be able to solve the specific problems of the market. Because the same model, but if it's not accurate as to solve the specific problems, and I don't know, having or detecting the proper things, analyzing the proper features that the clients want to start for the images, if it's not exactly when you are talking with corporates, it's extremely difficult to solve something. So I think it's more like knowing specifically the requirements of what you need to do with these models, and then putting the technology to work on it. So
right. To what extent, and you mentioned billions of images, to what extent data set availability or even data set augmentation is an issue here?
Deep learning is a gigabyte of data. You know, it's and as bigger these neural networks are becoming with years, you need more data to extract advantage of this kind of algorithms. No? So yeah, you need tons of data. And data availability is a big challenge. It's true that at the end of the day, you can build small models that are solving specific problems, and sometimes you don't need a lot of data depending of the problem. Okay? But depending of what you want to do, you can go. For example, we have models that are right now working pretty well with thousands of images, and then we have another models that are working with millions of images in the training data set. So depending of the problem, depending of the nature of this data, you have a lot of variants of the data you need. especially for medical, one of the challenges is obviously availability of the data. I mean, you don't have a lot of data. The quality of the data is not like a it's not like a 4K image of a house, you know. So it's different challenges. You need to apply different algorithms to try to augment this data, to try to fix this data before going to the classification neural net. I mean, it's a big wall with a lot of technologies or methodologies that you can apply to play and to surpass or to work around in these challenges. So.
Also, at the same time, even though the world of deep learning and machine learning in general is older than people think, right? we have algorithms that are decades old, but what has been changing, correct me if I'm wrong, is the underlying technology, right? We went through the AI winter because we didn't have enough machines or GPUs to run our things. But even with all that, since you guys have started until today, during all these years, the technology has leapfrogged several times, right? Today, you do things that you couldn't do last year and 10 times better than what you could do 3 years ago. We talk about things like AutoML, and so there's plenty of things. How has your company technology stack and way of working evolved since you envisioned the company?
Yeah, that's a very interesting question. It's true that deep learning neural nets are, I mean, Jan LeCun was working with neural nets and doing character recognition a lot of years ago. I mean, before even having the first GPU in the market. Then how are we able now to work and to do this at a scale? No? Because at the end of the day, the hardware, the GPUs, the TPUs, the tensor units are now allowing us to compute these crazy big neural nets at real time. And this is something that it's incredible. In terms of technology, it's very interesting because this week we were having a company, we were building a company deck where we were analyzing the performance and the speed that we were having back in 2016, more or less, compared to now. And the metric that we are having is just that we are now 40 times faster, you know, so it's crazy. And not only we are faster, that now we are able to use bigger models. Now we are able to host more models in the platform. I mean, okay, instead of having 2-3 models at the beginning, now we have more than 30 published in the platform, working at the same time, at the scale. We started processing like thousands of images, and now we are processing billions of images per year. And and this is not only, I mean, obviously we have put here a lot of development, but also the development of the field itself with new architecture, with faster libraries, frameworks, optimizations, faster GPUs also, and newer GPUs, allowing us to do this. So it's a combination of what you do and what this underlying development of hardware and software, this development is going to affect you, know, and your ability to do this at the scale. So it's super important.
So arguably, these many years ago, it was much more difficult to prove a certain advantage on a segment, right? Because you had to almost do everything by yourself.
Yeah.
Right.
Completely.
But now there are many more ad hoc models or even plug and play systems where you just put your data on a database somewhere and boom, you get stuff out there. Tell us a little bit, what was the moment where you said, maybe during the generalistic or general case part of the company, but when you said, maybe you saw an algorithm or a data set and you said, holy cow, this is it, this is where we have to go, this is where we need to be, and why?
We had we have different moments in the journey of this company to that. We started, for example, in 2016 working with Wallapop, helping them to avoid drugs in the platform, and that was something we needed to work with a data set with different lightings, different occlusions on the images. That was our first big challenge in the company, I think, in terms of data. and not only the data, no, because the neural nets that we were able to use at that point obviously were smaller because of the performance and the production requirements. And then we started talking more and more in the real estate market with real estate clients, and we Idealista became our client. So basically, at that point, we said, okay, this market, it's a market that is using a lot of images. This market is not now extracting information of the images that are the property images. No, they are not extracting information from the property of the images, and this market is huge, and we started building big data sets on that. We started with the thousands, then we were to hundreds of thousands, and then now we have millions of images in our data sets. And we are also increasing the complexity of the features that we are extracting. No? And let me just put an example. It's not the same, for example, to build a data set, say, okay, these are a simple image classification case, like, okay, this is a kitchen or a bathroom, no? And you have kitchens and bathrooms in 2 classes, and then you train your neural net. But imagine that you want to say, okay, this is a kitchen with a kind of stone countertop, with stainless steel appliances, with tile floor, with this kind of backsplash. So this kind of, when you are in this kind of detail, you need a lot more data, and this data is a lot more complex to annotate and to build. So it's kind of the complexity it's like exponential when you're doing this, and it's a real challenge. It's one of the real challenges in terms of data. No, it's how to build these data sets. But at the end of the day, we, with our experience working with our clients and knowing what they need, we said, okay, this is the path we need to go. At the end of the day, if something is so easy, I mean, you don't have barriers, and everyone can do this. So when you find a problem and the complexity to solve this problem is so high, but you have the way to do it, I mean, we said, okay, let's do it. Let's go to this market. Let's understand better what they want. And we started with the small MVPs. We started solving one problem, and then we started building more models that were solving another problems of these specific same clients in the same market. And then we were like this, like putting pieces, this small MVPs, and then evolving these MVPs to final products. And that more or less was the way how we said, okay, let's go for it.
This actually leads perfectly into my next question, which is, I think one of the headaches on scalability of AI companies.
Mm-hmm.
Right? So we're saying that models tend to be extremely domain focused, and in many cases are custom for the specific use case, right? Mm-hmm. Or in almost most cases. Yeah. Yet at the same time, if you want to scale your company, you have to be a product company, productize your models. So how do you consolidate those two, right? We get all these data sets, they keep improving, we keep testing new models. It feels like every client is a consulting client.
Yeah.
And then sure, you productize that model, but that model is not going to stay alive as is for long, right? It will keep evolving either because of technology, new algorithms, new data, or new features, or just efficiency improvements. How do you consolidate those two things?
Wow, this balance has been one of these challenges of my company over the years. We are started basically trying to extract this information from different clients and trying to build the common problems as a product. But it's true that over the years we were customizing a lot of things, and this is a pain for scalability. It's so difficult to scale when you are dedicating so engineering time to customize things, because I mean, it's something that is difficult. It's something that at the end of the day, I think a lot of startups are start like this. I mean, at the end of the day, if you have to to sign a contract with a client that is strategic and whatever, and they say, no, but I put this. At the end of the day, when you are like 3, 5, 10 people, or even more, at the end of the day, you have to say, okay, let's do it. No, but it's true that this is not sustainable over time. This is not scalable. And what our journey was like, okay, we did a lot of customizations, but then we were getting this feedback of the market and these common trends over for this specific target, and trying to say, okay, these specific kind of companies in this market and in these submarkets, because the real estate has a lot of submarkets, are having more or less these problems. Okay, so try to go for the big problems and trying to solve 95% of the problems with one product and focusing on developing that product. And in that way is where we ended from customizing everything to right now we are customizing a lot less than in the beginning. I mean, we are almost building products and only focusing on building products, because at the end it's what you need for scalability. It's not impossible. You can have, I mean, I don't know, whatever engineers you want, but it's difficult to scale. And at the end of the day, consulting, it's nice, and you can do consulting and at the beginning you have to do consult, or some of the companies, a lot of the companies should do consulting to be alive at the beginning, no? Because at the end of the day, you need your runway, you need your to pay everything. But it's true that obviously the multipliers in the case of an exit or whatever are not the same. So your path should be find the product market fit with your products and auto-scalable products. That's the
Bro, even when you try to raise capital from a VC or
exactly.
from any fund, right? Well, speaking of which, how is the raising capital? You know, I'm touching the hard questions. The raising capital for a company in AI, especially when it was in Spain, as early as you guys were there, not that long after the winter, the AI winter, there was still skepticism. Of course, all that was over, but it was like the after 2000s of the internet bubble, right? But for AI. So what can you tell us about, I don't know, do's and don'ts on for the smallest startups trying to raise money for maybe a pre-seed or a seed on their projects?
At the beginning, one of the challenges that we had is that obviously we were an AI company doing something new. Okay, one of the challenges that we had with some of the clients at the beginning is that one of the first things that they said was, "I don't believe this is possible." We are talking in 2016 that a lot of corporates were even saying, "Okay, what's computer vision?" You know. And when that happens to you, you need, at the beginning of everything, you need investors that are visionaries. Because if not, it's difficult. It's difficult to raise money because of your business vectors. It's more like, okay, I think this is going to be the future. No? So in late 2016, during 2016, we were like exploring, we signed the first clients. We had some validation of the technology, validation of we are solving the problems, the platform and everything. And then in late 2016, we were presenting the technology in the tech branch in the US. That was like a big difference for us because we were 3 people at that point. We were starting a business and we had a nice technology that was solving some problems, but not a lot of problems in the market. That for us, I think, was a key factor to raise our seed round. We raised a lot of interest in the US. Was very difficult for a Spanish company to raise capital in the US, but even taking that in consideration, we had one investor that was a visionary there. And without meeting with him face to face, because the conversation started when we were in Barcelona after the crunch, he said, "Okay, I invested in the past in a technology company that was succeed in Apple, so I have good experience. I like that kind of investments. Let's do it. And we raised the beginning, the first money that we raised was $100,000 directly from the US. He said, guys, I like the project. I mean, I know that you are so early because we were like even pre-seed, 3 people, but I like the technology. I'm going to send you the money. And with this money, we were able to get to May 2017 and raise a round with 1.2 million with our Spanish investors. And with these Spanish investors, we had very good experience and was a good process. I mean, obviously, we were in the kind of split decision where we were to say, okay, let's raise more money at higher valuation, because the hype of the technology at that point was so high, and we had the opportunity of saying, okay, put this crazy big valuation for the potential, okay, and raise a lot more money. But we talked with experienced people, and they told me something that helped us a lot, and saying, okay, guys, you have a great technology. For now, your business KPIs are starting to grow. Be cautious with the valuation, because not always a big valuation is going to help you. Because if you put a very big valuation and then your business KPIs are not growing as you think, or the adoption of the technology is slower than you think, you can be in a huge problem with the Series A. Because if you go down between series, this is very bad for you.
A disaster, right?
It's a disaster.
This is applicable to any startup, right? Not
only
in AI. But perhaps in an early field like AI, where you don't have a lot of certainty on how the industry is going to evolve.
Exactly. And something that happened to us, that the interest of the market was at that point started to be so high, especially in the US, also in Spain, but especially in the US, the interest started to raise like crazy. But the problem was that we were talking with a lot of companies, even corporates. For a company at that point, we were like 10 people in May 2017. We raised that 1.2 million. We saw the interest of the market. And we said, okay, this is going to be skyrocketing. This is going to skyrocket because this interest is huge. We are talking with corporates that are, public companies in the US, like in the NASDAQ, and we were like a 10 people company at the beginning. And we said, okay, the budget of this year is going to be like this. For sure, right. Because we are receiving the signals. But then what happened is that these companies were not able to apply the technology because they didn't know what to do with this technology at that point, because they were starting to know what computer vision was. So it happened to us that, okay, at the last stages of the conversations of the contracts, they went to the management or the CEOs or the boards of the company and said, okay, we need to do this investment in computer vision, but we don't know exactly what to do yet. And then because of this, we grow a lot in terms of people. We achieved like 20 people in 2017 or something like that at the end of the year, and we were burning like a lot of money. So in 2019, I needed to raise more money. It's something that for me, it's I always say that I cannot say people what to do to entrepreneurs, but I can say some things that you should avoid in the future. This is one of these. I mean, don't start burning money like crazy if you don't have the validation that the clients are going to pay this money and you are going to grow your business KPIs. Because it's risky. You grow like this, the market goes like this, and this gap is going to kill it. It's going to kill it.
Exponentially, absolutely. No, and this is an incredibly good point. We see more and more, especially nowadays, that there is money around, right? And of course, when you talk about the first round that you raised, it was in a different time. That was a lot of money back then. Today, maybe seed rounds are being seen like that, and there's like an explosion on investment. But back then in 2016, 2017, funding rounds were much smaller than what we see today. So we see a lot of entrepreneurs coming and saying, hey, I have a great idea. This is my potential product market fit that I'll have to validate. And I want money to build a prototype, and I need to hire 5 data scientists for doing that. And they want to go crazy and start spending 1 million a year or more without even having something like that. So I hear you on the need for validation first, maybe the need for analyzing a segment or a specific problem, and then not burning a lot of money. But if I am trying to start a company now, and yes, with the technology and the tools that we have today, how can I try to at least validate that now that clients have a bit better understanding on what to use this for before going crazy and start hiring data scientists, which we will talk in a minute how easy or difficult it is to get them?
If I have to start now, I would say, okay, let's raise like pre-seed. Let's raise a pre-seed with idea, with a PowerPoint with idea, even before the technology. Okay, even before building a platform and hiring data scientists, raise this money and use this money to do the minimum available product for validate technology, but the minimum, okay, like a test, like a prototype, but very minimal, and then use this money to, if you don't have the knowledge of this market that you are addressing, or you don't have the knowledge of the problem, the potential problem, just try to find someone that knows that. That just to find someone in the market that has that experience, talk with them, try to find this information, try to validate at least the problem, and with this minimal viable product, try to talk with this company, do 1, 2, 3 tests with different players in the market, and try to validate it. Even if this product is not scalable, even if this product is not real time, even if it's just, okay, I don't know, an example could be at the beginning we had an API. We had an API where the clients were able to in real time to send whatever. If I have to do this now, I would say, okay, just a proof of concept with the clients where they send us the images, we do our processes in background, and we send them back a result, which is a lot easier, which requires a lot less funding in the terms of the technical part. And if they say, hey, with this, we can solve this problem, and the business case is we are saving blah, 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 blah. Okay, we are saving this money, or we are making this money more at the end of the year, we increase the revenue by whatever. Trying to establish this relation with these players in the market, 1, 2, 3, trying to have this data, not the business case. Trying to build the business case. Okay, what's the business case? Okay, they have this problem. With my MVP of this technology, I can solve this, and they can reduce this cost, or they can increase this revenue, or they can have a competitive advantage over the competitors, whatever. Trying to build this business case for me would be one of the first steps. And we were like, at the beginning, we were like at the other way around. We were, as an example, we were the first API in the world, even before Google Vision, providing object detection in real time, like in real time, and with an API integration. So cool, so beautiful, but we didn't have the business case perfect, and that costs a lot to burn a lot of money before finding it. So that would be my. It's not always easy. I mean, I remember when I was starting this, reading the lean startup book, the examples of, okay, you need to do the minimal, and obviously it's not easy. But my advice here would be, let's try to do the minimum and validate the problem. Just validate the problem. Fall in love with the problem, and then you will find the solution.
That is super interesting and
Yeah.
invaluable advice that I think is exactly right.
Yeah.
Again, probably not only for AI, but for any type of
It's
startup.
probably for a type of business.
But in AI, perhaps it's a little bit more difficult because you need also the technical feasibility
Yeah.
on whether there's going to be an advantage or an efficiency improvement on
Yeah.
that. Let's switch gears a little bit and kind of building on what we've been discussing. How did you become a data scientist?
It's when I was in the university, finishing my university.
What did you study?
Computer science.
Computer science.
Computer science, and in my last year, I started working in a project that was at the end of the day my final thesis about facial recognition. Facial recognition. At that point, I'm saying that it was like 2009 or 2010, something like that. Was into 2010, I think. And then the challenge there was that at that point, the facial recognition algorithms were like the pretty basic before any deep learning computation, because the neural network existed at that point, but we were not able to compute it, so it was impossible to use it. So I did a thesis about this a system that was working in a bigger board, which is a device that is like a portable device. And that device at that point was able to detect faces, which was the easy part. It was the easy part. And then recognize it, do a kind of algorithm with agent faces, with extracting the agent vectors, the common, or the extracting the features that are identifying the are differentiating the faces between them, trying to extract the agent vectors, projecting that in a space, doing a PCA, and then with this PCA projecting new faces and trying to identify people and trying to learn people on fly. No, that was more or less my thesis. And at that point, I felt in love with that. I mean, that was one of the things that were motivating me more. And from that point, I started investigating and working on that from my side. And then in 2014, we started talking about the technology. And at that point, in 2014, the first ImageNet challenge, in the first ImageNet challenge, a lot of these neural nets, deep neural nets, were showing strong abilities to identify images. No? So I said, okay, I have these years of knowledge doing this, trying to work with computer vision traditional algorithms. I have a knowledge of how this neural net works. And then I say, okay, now we have the ability to put this at the scale. Now we can do things for the real world for this. And this is how this journey started, and since now. So.
That is quite amazing, right? You said, no, you're doing principal component analysis in 2008 or 9. Like today, you do that with one line of code and your laptop, but back then, probably you needed quite a few dozens or hundreds of lines of code and a few hours of computation, right? Different times. So now, of course, time has changed, and we have not new, but new generations of data scientists, including the ones that are studying with us here on BTS. And they come with completely different background and baggage and experiences, and mixing domains from different places, different backgrounds and all that. Mm-hmm. On Restb.ai, what is what you look for when now that you say you're trying to scale up the company and hiring? What is what you're looking for specifically on data scientist or data engineer?
Yeah, it's we are clearly. I mean, our focus for now is computer vision. But the domain of data scientists is at the end of the day people with experience on dealing with analysis of data. And something that for me so important is experience dealing with big amounts of data, because this changes a lot how the pipelines and everything needs to work. And it also changes the algorithms that you can use, no? Because at the end of the day, for some of the algorithms to work, you need a lot of data. So you need to build these pipelines, you need to build this pre-processing, post-processing pipelines, and these trainings pipelines, having that in mind. Something, and a clear example is at one of the first projects that we did in the company now. We were like ingesting the images. The first MVP was ingesting images one by one, like this, and then computing some features of the images. Obviously, when you scale your data set, that's impossible, and you need to build very efficient pipelines. And sometimes, as an example, you need to build efficient pipelines that are ingesting data that are not in a high performance source, like a disk or like a memory, system memory. They are like in the network or in other sources. Trying to understand and having experience on how to consume this data, how to speed these processes, because here what you have is that a small bottleneck can kill your process, because this bottleneck on this overhead in a small piece of the process can make this all pipeline unscalable. And from the other side, when we train our models, the models are trained and everything is ready, we do this validation, we run our validations, and we need to understand how the model is performing. That's the other part of data scientists for me. I mean, I see like two parts, two main focus for a data scientist is, okay, how I can ingest that data, how can train my models. Here in the training part is when we are talking about architecture selection, changing a model, changing the layers of the model, which is the deep learning research. Is more like an AI, pure AI research. And then when we come to validation of the model, it's like, okay, how this model is performing. And this part is so tricky also in AI company.
Right. So that's why it's called data scientist, right? Because you need to have a science mindset on hypothesis, experiment, and validation.
Exactly.
But very, very relevant. That's something I keep telling our students. It's not enough with getting a medium tutorial, a PyTorch manual, and then a Kaggle data set. Now you have to think about, what if I had billions of entries or training data points and thousands of features to play with, right? So you need to think more about the infrastructure and how you're going to test different models, how you're going to fine tune your hyperparameters. Perhaps the model itself is the easy, not so easy part, right? We're running out of time. I wish I could have time to keep talking for 2 hours, but I would like to close with just one more philosophical question, and perhaps tough. So if you could solve any problem in the world with AI, besides image recognition and classification for real estate, what would you like to, you have all the free time in the world and resources at your disposal, what would you like to use AI for?
I mean, there is a field that I'm super passionate about, which is understanding the brain. I mean, there are a lot of problems to solve. I mean, you can apply AI to solve cancer, which will be amazing also. A lot of different things. I mean, but something that is interesting for me, because there are few experiments that are showing that could be possible in the future, is understanding the brain. And with understanding the brain, I mean also decodifying the brain. This is like a crazy idea, but the concept is, okay, if you can map the signals of the brain with the feelings, or what you are seeing, or what you are hearing, or what you are feeling, then you can map this brain activity to a neural net and build what is called more or less a autoencoder or encoder-decoder. No? The neural net learns how our brain encodes these feelings or this information, and then when you can put a brain activity reader or whatever, you can extract this activity and you can show or create what this person is feeling. Like, okay, to feel things virtually, to extract images from the brain. Okay, like, okay, thinking something, and then you get an image with it, you decode this information and you get an image. Or okay, think about moving the arm, no? Something that Neuralink of Elon Musk is working a lot on this. It's like, okay, I have my robotic arm or whatever, and then I think, okay, I want to move the arm, and I move the arm because a neural net is decoding the brain activity and saying, okay, do this movement. It's mapping brain activity with movements, and I think it's a very interesting field because right now, as humans, we don't know what the brain is doing inside a lot of times. So probably it's difficult to know, but we can train a neural network to try to understand it and mean it. It's like something that we were not able to understand, but the AI can understand, and that for me it's beautiful.
That would be an amazing problem to tackle. We have one question from the attendees that I would like to tackle, if you don't mind.
Mm-hmm.
So there's new ideas coming out every day. Even here, we touched on some already. Ahmed asks, how can one be sure that your idea is new and no one else is doing it, or something like that?
I mean, at that point, you need to do obviously kind of market analysis, but for me the most important thing is talk with the players in the market, talk with the clients, talk with them. I mean, go to them, present the idea, have a meeting. I mean, at the beginning I was thinking that people is not so open to talk, but then you find that people is open to talk, and businesses also are open to talk. At the end of the day, you think of, okay, this is the CEO of this company or the CTO, and they are so busy, but they at the end of the day, they are people, and they like other people, and they like to know new projects. They want to know how to innovate. So just go there, get a meeting, talk with them, and say, hey, do you have this problem? And if do you have this problem, are you using another solution in the market? There are other solutions in the market. Talk with them, and you will learn from your clients. It's my main advice.
Absolutely. Thank you very much for that answer. Let's wrap this up just with something you would like to tell our students, especially the big data and artificial intelligence students, some words of advice or encouragement now that they are about to dig deep into Spark and real-time analysis and stuff like that.
I think something that I think it's important is, first of all, you have an incredible opportunity in front of you. I mean, the AI is going to grow a lot the next years. I mean, it's crazy. Also with other technologies like quantum computing, which Sergio knows more about that. But AI is going to grow a lot. You have in front of you incredible opportunity, something that you will have to deal with, and something that it's different from other technology developments is that deep learning or AI is a science, okay, and it follows a scientist method. You need to do the hypothesis, experiment, and validate. This is something different that in when you are coding an application. No, with the application, okay, it does this and it always does this, and this has always, because it's not as deterministic and other things. You have probabilities, you have this recall, precision, specificity values. When you are moving this to a real world business, this is also a challenge because your clients need to understand that, okay, but this is going to work or this is not going to work. It's not like a database, no, that is always the same. The code is always doing the same. Here, no, you have these probabilities. You have, for some of the images can be more confusing, for some of the images can be more, the neural net can be more sure about the decision. So it's a science. It's a bit different from other technology. If some of the people is coming from programming or whatever, it's the main difference. You are not programming something and it is working the same way always. No, it depends on the data.
Not deterministic.
Not deterministic. I mean, it depends on the data, depends on the real world scenario, depends on the use cases. You can have, for example, a model which is so good but then in the real world you have like I don't know, 1 million images without I don't know, if you are, for example, detecting violations, something that happened to us. You are detecting violations in photo compliance, for example, people, no? And then your client has 1 million images. From each 1 million images, only one has a positive. Okay, your model is going to have a precision like 0 precision, because even if your model is incredibly good, I mean, you need to be aware that your metrics in the real world are going to raise a lot of false positives, because at the end of the day, a lot of the images that are going through the model are false positives. So a lot of these things to think about it, a lot of these things to try to make the models to work, thinking in the real world use cases. Okay, very, very important. And yeah, it's so exciting. It's a world that is my favorite world, and I think the opportunity here is crazy good. So let's work on it. Let's keep it. Let's keep working. Let's be curious and read papers in the internet. Trying to understand the new methodologies, the new state-of-the-art networks that are showing up, and yeah, a lot of things to do, a lot of things to solve, and a lot of problems to solve in the future. So
that's really, really amazing, Angel. Thank you very much for coming today. Always a pleasure to have you here, and BTS is always your home. I hope everyone enjoyed the session today and learned. I definitely learned a lot myself. I could speak with Angel for hours and hours and geek out and all that, and we didn't even touch the code. But yeah, it's amazing stuff, and really, really fantastic to see examples of companies from the startup scene in Barcelona, in Spain, that are growing and making a very good case on AI. This is exactly why we're doing all these type of things. So thank you everyone for coming. We'll see you in the next BTS Talks. Angel, again, thank you very much. BTS is always your home. And until then, peace out.
Okay, thank you so much, everybody. Thank you, Sergio. Bye-bye.